Hello students, welcome to Aryadi classes. Today here I am teaching most important results, okay, and shortcuts on a topic derivatives. Result number first, if a raised to x plus a raised to y is equals to a raised to x plus y, then dy upon dx is equals to minus y by x. In place of a, suppose here 2 given, 2 raised to x plus 2 raised to y is equals to 2 raised to x plus y. Then also answer dy upon dx is equals to minus y by x. Yes, then 2 or 3, okay, answer minus y by x. Number 2, most important result, if y is equals to f of x is a differentiable function, then d2x upon dy square is equals to minus dy upon dx whole bracket raised to minus 3 into d2y upon dx square. Next, or in place of suppose d2x upon dy square, question d2y upon dx square in place of d2x upon dy square. Then right side equals to d2y upon dx square as it is. This is minus power here, dy by dx raised to minus 3 into term in the left becomes upon, okay, and then next in the numerator it becomes dy by dx raised to plus 3, okay. Therefore d2y upon dx square is equals to minus dy upon dx whole bracket raised to plus 3 into d2x upon dy square. Yes, then next most important result, third, if x is equals to f of t and y is equals to g of t, where t is a parameter, we know that derivative of parametric functions, okay, x is equals to f of t, y is equals to g of t, then d2y upon dx square is equals to minus 1 upon x cube y, answer, or minus y by x, okay, or d2y upon dx square is equals to minus y by x value, okay, minus y by x answer. Both correct answers. Then next number 4, most important result, if x square plus y square is equals to t minus 1 by t and x raised to 4 plus y raised to 4 is equals to t square plus 1 by t square, then d2y upon dx square, derivative of parametric functions, d2y upon dx square is equals to, here we get is equals to f dash of t into g double dash of t minus g dash of t into f double dash of t whole divided by f dash of t whole bracket raised to not 2 power 3 power 3. Most important result here, power 3, derivative of parametric functions. Then next number 5, if y is equals to tan inverse of a cos of f of x plus b sin of f of x upon b cos of f of x minus a sin of f of x, here in the numerator plus and in the denominator sign minus, then dy upon dx is equals to plus sign, then here we get f dash of x, okay, and if in the numerator minus, term same, in the numerator minus and in the denominator plus sign, then dy upon dx is equals to minus f dash of x, minus f dash of x. For example, if y is equals to tan inverse of, in bracket, 3 cos x plus 4 sin x whole divided by 4 cos x minus 3 sin x, then dy upon dx is equals to, yes, here we get, then dy by dx is equals to, here f of x is equals to x, then its derivative, and here sign plus in the numerator, okay, f dash of x, that is derivative of x, x, that is here our f of x function, okay, its derivative is equals to 1. Okay, suppose cos of log x, then answer log x derivative 1 by x. Suppose here e raised to x given, then e raised to x derivative e raised to x. Okay, then next number 6 here minus f dash of x. Minus sign in the numerator, then minus f dash of x, and in the numerator plus minus minus plus. Okay, then we get here minus f dash of x. Then next number 7, if y is equals to function raised to function, same function. If y is equals to f of x raised to f of x, we know that type of function raised to function. Then steps are, step number 1, taking log on both the sides. Step number 2, using law of exponent, that is called power rule, and then next by product rule derivative. Okay, here step number first, function raised to function. Step number 1, taking log on both the sides. Okay, log on both the sides. Therefore here we get log y is equals to log of f of x whole bracket raised to f of x. Yes, then next part, log y as it is. Then in the right side, using log of m raised to n, n log m, n is equals to f of x into log of f of x. And then step here, this is our first function u and this is our second function v. Using product rule we get the direct derivative. Here we get dy upon dx is equals to, we know that derivative of log y, 1 upon y into dy by dx. Then 1 upon y in the right side becomes into y. In bracket here using product rule, u into derivative of v plus v into derivative of u. Therefore here we get f of x into derivative of log of f of x, 1 upon f of x into derivative of f of x, f dash of x, plus log of f of x as it is into derivative of f of x, f dash of x. Therefore here we get into f of x upon f of x cancel. Therefore dy upon dx is equals to, put y is equals to function raised to function, f of x raised to f of x, and here common part, yes, common f dash of x, taking common f dash of x in bracket 1 plus log of f of x. This is our shortcut. Okay, shortcut dy upon dx is equals to, for example, most important example, y is equals to x raised to x, function raised to function. Okay, f of x raised to like f of x, same function. Then for by shortcut we get dy upon dx is equals to function raised to function, x raised to x into f of x, this is our function. Then f dash of x, derivative of f of x means derivative of x is 1. Okay, x derivative 1 in bracket 1 plus log of f of x. Here our f of x is equals to x. Yes, therefore here we get f of x is equals to x. Answer x raised to x in bracket 1 plus log x. Most important example. Then next part, in place of suppose f of x raised to f of x, if y is equals to f of x raised to g of x, that is another function, then dy upon dx is equals to, yes, function raised to function, taking log, using power rule, and then differentiation. Therefore we get by direct here result, dy by dx is equals to f of x raised to g of x in bracket, here by power rule we get g of x, yes, g of x into log of f of x, yes, this is y. Okay, and then next you by product rule we get, by product rule, g of x into derivative of log of f of x, 1 upon f of x into derivative of f of x, f dash of x. Okay, plus log of f of x as it is into derivative of g of x, g dash of x. Yes, therefore here we get f of x raised to g of x into g of x upon f of x into f dash of x plus log of f of x into g dash of x. For example, year 2024 sin x raised to tan x example. Yes, y is equals to sin x raised to tan x, that is function raised to function but another function. Therefore, by result we get dy upon dx is equals to, this is f of x and power is equals to g of x, sin x raised to tan x in bracket, yes, power tan x as it is, into 1 upon f of x at sin x into f dash of x, derivative of sin x, yes, derivative of sin x cos x, plus log of f of x is equals to sin x into g dash of x, that is derivative of tan x sec square x. Okay, this is our answer. And here the next adjustment, tan means sin by cos. Okay, tan means sin by cos, into sin upon sin cancel, therefore here we get cos x. Okay, cos x here term also, here common given log x, sorry 1 minute, here another example, log x raised to sin x. Okay, this is our required answer. Sin इथे तुम्ही असंही करू शकता ना, tan means sin by cos into sin upon sin cancel, term cancel करा, बाकी ते ऑप्शन बघून ऍडजस्ट करू शकता. ओके, नेक्स्ट एक्झाम्पल, yes, next example, log x raised to sin x. Okay, homework example. Then next, if y is equals to, 1 minute, next point, number 9. Okay, number 9, if y is equals to, here given thing, determinant of PQR, second row UVW and third row LMN, then dy upon dx is equals to, derivative of first row. Okay, here all are suppose P, Q, R, U, V, W, L, M, N, all are functions. Okay, then here P, Q, R, derivative of P with respect to x, Q with respect to x, dq by dx, R with respect to x, dr by dx. Second row as it is, okay, third row also as it is, plus first row as it is, derivative of second row du upon dx, dv upon dx and dw upon dx. Third row as it is, lmn, plus first row as it is, pqr, second row as it is, uvw, and derivative of third row dl upon dx, dm upon dx and dn upon dx. Okay, this is method to find derivative of determinant. And next result, suppose UVW and LMN are constants. Okay, UVW and LMN are constants, then we know that derivative of constant 0, constant derivative 0. Therefore, here we get in second row all elements are 0, 0, 0, and here derivative of third row elements, that is LMN, 0, 0, 0. And then after here expansion, we get last part 0, second part 0. Therefore, result number 10, if y is equals to PQR first row, second row UVW and third row LMN, where UVW, LMN are constants, then dy upon dx is equals to determinant of second row elements as it is, third row elements as it is, only find out derivative of first row elements. Yes, first row elements. dp by dt, dp by dx with respect to x derivative, dq by dx and dr by dx. Okay, these are the some shortcuts.